In this video, we'll be writing equations of lines. I want to start by introducing point-slope form of a line. Y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a point on the line. This form of a line is really only useful for writing equations of lines. It's not the only form of a line, though, that we can use to write equations of a line. We can also use point-slope form, y equals mx plus b. So throughout this video, when I'm writing equations of lines, I'm going to demonstrate how to use each form of a line to write the equation. You choose whichever technique you're more comfortable with. So let's find the equation of the line that contains the given point and has the given slope. We want to write our answer in slope-intercept form regardless of which form of a line we use to actually write the equation. We do this because slope-intercept form tells us a lot of information about the line, and then if we want to do subsequent things like graph it or answer a question to an application problem, it's the easiest form to reference. I'm going to start by using our new form of a line, point-slope form of a line, to write the equation. I always start by identifying the x1, the y1, and the m that I'm going to be plugging into this formula. Plugging in, we get y minus 3 equals negative 1 times the quantity x minus a negative 2. We want to clean this up. That minus a negative 2 becomes x plus 2 inside our parentheses. We'll distribute the negative 1. Y minus 3 equals negative 1x minus 2. And of course, actually writing the 1 in front of the x is optional. And then the last thing we want to do is get it in slope-intercept form, so we need to isolate y. We'll add 3 to both sides. This gives us the equation y equals negative x plus 1. And that's the equation of the line that passes through the point negative 2, 3, having a slope of negative 1. Let's do the problem again, but this time we're going to use y equals mx plus b to write the equation. This process has a couple steps to it. The first thing we want to do is plug in y, m, and x. Our x and y are the x and y from our given point. And then our m was given as well. So this will be 3 equals negative 1 times negative 2 plus b. The next thing we need to do is solve for b. We'll have 3 equals positive 2 plus b. Subtracting 2 from both sides, we get b to be equal to 1. Now that we've solved for b, to actually get the equation, we're going to plug the m that was given and the b that we found into y equals mx plus b to get the equation of our line. We'll have y equals, our m was negative 1 times x plus the b that we found, which was 1. Y equals negative 1x plus 1. We see that we get the same answer with either technique. Practice both of them and then just decide which one you're more comfortable with using. There should never be a time where you're forced to use one or the other. Let's try another example. Let's write the equation of the line that passes through the point 4, -1 and has a slope of positive 3/4. Start by using point slope form of a line. This technique is actually my personal preference, just because all I have to do is plug in the numbers and clean it up. Yes, I have to learn a new equation, but for me, it's worth it. So we'll have our x1 and our y1, plugging it into our equation. We get y minus a -1 equals 3/4 times x minus 4. Change that left side to be y plus 1 and distribute the 3/4 on the right. That'll be 3/4 x minus 3. Those 4's are going to cancel out when we distribute that fraction. And last thing I need to do is isolate y, so we'll subtract 1 from both sides. This gives us the equation y equals 3/4 x minus 4. Let's do it again using y equals mx plus b. 4 is going to be my x, -1 is going to be my y. I'll plug in x, y, and m, solve for b. So -1 equals 3/4 times 4 plus b. We multiply those fractions together, and as I mentioned before, the 4's cancel right out. That's -1 equals 3 plus b. Solving for b, we get -4 equals b. Now that we've found our b, we're going to plug b and the slope into y equals mx plus b, and that'll give us our final equation. Y equals 3/4 times x plus our b, which happens to be negative. So rather than writing plus -4, let's write y equals 3/4 x minus 4. In our next example, we want to write the equation of the line that passes through the point -1, 5, and has a slope of 0. So right away, when I see this slope of 0, a red flag goes off for me. Anytime the slope is either 0 or undefined, I know it's either a horizontal or a vertical line. Here, the slope is 0. That tells us right away that it's a horizontal line. Although I could plug these numbers into one of the forms of a line and get my equation that way, it wouldn't work if the slope was undefined. You can't plug the word undefined into an equation for a variable. So what I like to do with these special case ones is draw a picture. I know this is a horizontal line passing through the point -1, 5. So here's -1, 5. There's my line. I'm just going to write the equation. If you recall, horizontal lines are always y equal to a number. I have trouble remembering that, so what I always think of is what equation is the line what axis is the line crossing? Whatever axis it is crossing, that's the variable we're going to want to use. So it's crossing the y-axis, so I know it's going to be y equals a number. And just look what y value, y equals 5. In our last example, we want to find the equation of a line that contains 2 given points. Well, in order to write the equation of a line, you have to have 2 things. You must have the slope and 1 point on the line. Here, we're only given 2 points, so that satisfies the second requirement, but it doesn't satisfy the first. We need the slope. But if we're given 2 points, we can find the slope by using our slope formula. M equals y2 minus y1 over x2 minus x1. We're going to have to do that first to have enough information to write the equation of our line. So our slope, and I always like to label my points. Our slope is going to be 5 minus 3 over 5 minus 2. That gives us 2/3. Now that we have our slope, we can just choose either one of the given points to use to write our equation. I always avoid, well, my first choice is a point that either coordinate is 0. So that's what would be my first choice. If that doesn't occur, I would choose whichever point had the least number of negatives. Now, both of these points are all positive, so just pick one. I'm going to pick the first one. So we're writing the equation of a line that has the slope 2/3 and passes through the point 2, 3. In this last example, I'm only going to use one of the techniques. I'm going to use point slope form. Y minus 3 equals 2/3 times x minus 2. Distributing on the right side, we get y minus 3 equals 2/3 x minus 4/3. Last thing we want to do is get it in slope-intercept form, and we'll do that by adding 3 to both sides. Negative 4/3 plus 3/3 gives us positive 5/3. You can just pop that in your calculator. If you're going to do it by hand, make sure you get a common denominator. That plus 3 is going to turn into 9/3. So y equals 2/3 x plus 5/3. If you prefer using y equals mx plus b, well, just give it a try and double check your answer with mine. All right, one more example. Let's write the equation of the line that contains the point 3, 1 and is perpendicular to the line y equals negative 2x plus 5. Well, we know in order to write the equation of a line, we have to have the slope of the line and a point. They've given us a point, but haven't explicitly given us the slope. They have, however, told us that we want to be perpendicular to the line y equals negative 2x plus 5. Well, the slope of this line is negative 2, and if we want to be perpendicular to that line, perpendicular lines have slopes that are opposite reciprocals, so we're going to want to use the slope positive 1/2 and then write the equation of the line having that slope and passing through the point 3, 1. I'm going to use a point slope form. Y minus 1 equals 1/2 times x minus 3. Y minus 1 equals 1/2 x minus 3/2. And adding my 1 over, we get y equals 1/2 x minus 1/2.